Next after that it is the moment of momentum or the angular momentum. Now we are coming to that very important concept, that is the conservation of angular momentum. So first of all, when you are coming to the conservation of linear momentum, in that case, when there is no external force acting on that system, when there is no external force acting on that system, then total momentum before collision is equal to the total momentum after collision. That is, the total momentum, total linear momentum will be conserved when there is no external force acting on the system. Similarly, here also, when there is no external torque, in place of the force a torque comes. So that's why when there is no external torque acting on the system, total angular momentum is conserved. Its meaning is, that is the total angular momentum is conserved means it is the I1 omega 1 is equal to I2 omega 2, and it is the I1 omega 1 is equal to I2 omega 2 means I inversely proportional to omega. So it is the when there is no external torque acting on the system, total angular momentum is conserved. That is I1 omega 1 is equal to I2 omega 2, I inversely proportional to omega. Now there are so many applications are there on this conservation of angular momentum. Its meaning is the animated bodies and again the inanimate bodies both follow that conservation of angular momentum for their stability. Suppose for example, there is a famous example is there. Now here it is a circular disc is here and a person is there. He is standing on this circular disc by holding the dumbbells, like this. So these are the dumbbells here. Now in this case, when he is holding the dumbbells and that circular disc is rotating with some angular velocity. With some angular velocity it is rotating, and now he is standing on that. Now when the dumbbells are like this, then he appears to be that he is rotating very slowly. Why? Because the dumbbells are far away from his body axis. That's why I value is greater, because I value is greater and omega value will be less. I value is greater because I is the mass into distance square. So that's why I value is greater and omega will be less. Suppose if at all he is bringing those two dumbbells close to his body like this, then automatically I will be less and omega will be more. There is no any change in the rotational speed of that circular disc. Even then, only because of that internal changes, there is not at all any external torque. Only because of that internal changes, he is able to increase his rotational speed. That is, the I is decreased and omega is increased. So like that there are so many applications. Suppose for example, you are given some raw egg and again that boiled egg, hard boiled egg. Raw egg and again the boiled egg. So in these two cases, how do you identify? That is also one of that examples based on this conservation of angular momentum. Now how do you identify which is the raw egg and again which is the boiled egg? So raw egg means inside it will be the fluid is here, completely inside there is a fluid, and boiled egg. So in that boiled egg means that too it is a hard boiled egg. So like this, so it is the raw egg and it is the boiled egg, and both are given the same angular velocity and both are rotated with the same angular speed. But here in this case, that raw egg comes to rest quickly and boiled egg, it takes some more time to come to that final rest. Why? Because in this case, raw egg, when it is rotated with some constant angular speed, then automatically the inside fluid that moves away from that axis, that inside fluid reaches this inside walls and it moves away from the axis. That's why here the I is more. I is equal to mass into distance square, and that's why I is greater here and automatically omega will be less here. Suppose when you are coming to this hard boiled egg, then in that case, even though it is rotated with angular velocity, there is no any change in the inside particles. There is no any change in the position of that inside particles. So that's why here the omega will be less. That's why it comes to rest, and there is no any change in that omega. So that's why it takes some more time to come to that final rest. So that's why it is the raw egg and the boiled egg, and we can identify them based on that conservation of angular momentum. Now here we are coming to this one more example. Suppose if Earth is taken like this. This is the elliptical path and the sun is at one of its foci like this, And here, when the earth is rotating in this elliptical path, when it is far away from the sun, and suppose if at all it is taking the 30 days to come from this position to this position, and it moves slowly. Similarly, when you are now, when it is nearer to the sun, again it is also taking the same 30 days. In this case, it moves fast. So it is the same 30 days is here, it moves fast. Already this is nothing but the familiar law, that is the Kepler's second law. That is a law of areas. Line joining the sun and the planet sweeps equal areas in equal interval of time. Actually, what he has observed, that is what that Kepler observed, when it is far away from the sun, it moves slowly, and again when it is nearer to the sun, it moves fast. So now here it is also obeying the conservation of angular momentum for its stability. It cannot maintain the same angular speed throughout that path. If at all it is maintained that same angular speed throughout that path, then it cannot continue its motion in the same orbital path. So that's why when it is far away from the sun, that is the I is more and omega is less. I is more and omega is less. So that's why it has to move slowly. And again when it is nearer to that sun, I is less. And again the omega is more, omega is greater. So that's why conservation of angular momentum is obeyed here also. Now not only that Earth and any planet in this planetary system, they also obey that conservation of angular momentum. Now we are coming to some different examples. Suppose one more example. If all the people go to Antarctica, it is only that imagination. If all the people go to Antarctica, what happens to the duration of the day? And that is remains unchanged, or the decreases or the increases like that. If all people go to Antarctica, suppose if at all, now here it is there, and again it is the west to east, it is revolving. If all the people go to Antarctica means, which is nothing but the polar axis. If they are moving, then I will be decreased. If all these people go to Antarctica to the polar axis like this, then I will be decreased. I decreases in this case, and again the omega increases according to the conservation of angular momentum, that is omega increases. Now we are coming to that formula, T is equal to 2 pi by omega. T is equal to 2 pi by omega, and it is the T indicates the, that is time period of that self rotation of that earth, that is said to be the 24 hours. Now T is equal to 2 pi omega. Omega increases means T decreases. Its meaning is, I mean to say, that's why here the earth completes its revolution less than 24 hours, in less than 24 hours. So once again I tell you, so first of all, when it is that earth is rotating in that from west to east along that equatorial plane, and in this case, if all the people move towards the Antarctica, that is on that polar axis, I will be less and omega will be more, and T is equal to 2 pi by omega. As the omega increases, the time period decreases. So that's why it completes its revolution or rotation in less than 24 hours. Now we are coming to that last application, last example of this conservation of angular momentum, and that is slightly difficult, and it is multi-conceptual also, that is based on that gravitation concept also. Now here, suppose if polar ice caps completely melt, polar ice caps, that is the icebergs, all these polar ice caps completely melt, then what happens to the pendulum clock, time shown by the pendulum clock, which is kept at equator? If polar ice caps completely melt, then what happens to that time shown by the pendulum clock? What happens to the time shown by the pendulum clock, which is kept at equator? So in that case, if at all it is a completely, that is a polar ice caps completely melt means it flows towards, then it floats towards that equator. It flows in all directions like this, then automatically I value increases. So when polar ice caps completely melt, then I value increases, then omega value decreases. Then you cannot go to this formula T is equal to 2 pi omega, because here you are supposed to find out that a time shown by that pendulum clock. That's why you have to take that formula which is corresponding to that pendulum clock. So that's why it is a T is equal to 2 pi root L by G is here. T is equal to 2 pi root L by G. Here there is no any change in the length of that pendulum before and after melting of that polarized caps. So that's why there is a change in only that small g. Because of this angular velocity, how that small g is going to be affected. So you have to find that. That is small g means already you know that is a g phi is equal to small g into 1 minus s. So that is a small g minus r omega square. And actually the formula is the small g into 1 minus r omega square cos square phi by small g. This is the general formula. This is a general formula based on this latitude that comes in gravitation. G phi is equal to small g into 1 minus r omega square cos square phi by g. Now here at equator latitude value can be taken as the phi is equal to 0 degrees. Phi is equal to 0 degrees at equator. So that's why GE is equal to small g minus r omega square. This will be the values. GE is equal to small g minus r omega square. When angular velocity increases, when angular velocity decreases, then GE value increases. GE value increases. When angular velocity decreases, according to this, then GE value increases. GE increase means from this formula time period, that is a GE decrease means a time period, GE increases, a time period decreases here. So time period decrease means it is nothing but the actual time increases. Actual time shown by the pendulum clock will increase because the time period and the time shown by the pendulum clock both will be opposite each other. Why? Because time period means it is the time taken for one complete oscillation only. And here suppose if the time period decrease means it is nothing but generally that pendulum clock will take that time period is 2 seconds. If at all time period decrease means it is completing its oscillation in less than 2 seconds. In less than 2 seconds, its meaning is it may complete its oscillation in the 1.8 or the 1.7 seconds. That's why here this pendulum clock is to move fast like this. Then in that case, when it is moving fast and these hands of the pendulum clock also will be connected to this movement. So that's why they move fast. Because of that, it is the gaining of time. Suppose if at all it is at 10 a.m. it is to show. Instead of that, it shows that at 10:15 a.m. like that. So that's why it is the actual time increases. Actual time increases. That is nothing but it is the gain of time. Gain of time will be there. Gain of time. So once again I tell you, so first of all this is slightly a difficult example based on this conservation of angular momentum. So far what I have explained. So now here the first one, once again I tell you, here it is, if the polarized caps completely melt, then what happens to the time shown by the pendulum clock which is kept at equator. In that case, when the polarized caps completely melt, I increases and omega decreases. And here then what is the effect of this angular velocity on small g? In that case we are taking that formula T is equal to 2 pi root L by G. That is the time period of that pendulum clock. And T is equal to 2 pi root L by G. There is no change in the length, only that small g will be affected because of this angular velocity. And to know how it is affected, this g phi is equal to small g into 1 minus r omega square cos square phi by g. At equator, phi is equal to 0, that is the latitude value is 0. Therefore, g is equal to small g minus r omega square. When omega decreases, then ge increases. So that's why ge increases. Then a time period decreases according to this formula. Time period decreases. Then a time period and actual time shown by that pendulum clock will be opposite to each other. Because of that reason, it is a gain of time. It is a gain of time. Now, these are the applications, some of the applications based on this conservation of angular momentum.